Now, before we go ahead and start writing the code, there's this one part that I believe needs a bit more explanation, which is on how we fill the table. So this is the initial table that we had, and we didn't fill everything. So now we're going to try and fill throughout the entire table, and then from there, next we're going to write our code. So the how the table layout is basically we have the rows representing this first string and we have the columns representing the second string. Now each cell is going to tell us how many characters are going to or rather how many characters match up to that point. And for now, we have what we had earlier. Also, we had already filled the first row here, and we're going to proceed to start filling the next other rows and columns that are remaining. The rules for filling the table are quite simple. So if two characters match, we're going to take the diagonal value and add one. And that is what we have here. We had here as the first thing. So if two characters match, we take the diagonal value and we add one. What that is going to mean is that we found a matching character. And if they don't match, then we take the maximum value from the top or from the left. What that means is that there's no match at that point, but we keep the longest match that we have found so far. And that is why in the first row here, we found that A and A, these are a match. So we added one here. But Y and B are not a match to A, but what you're doing is we're just keeping the longest match that we have found so far, which is one. And that is why we gave it a value of one here and a value of one at this point. So now we're going to go ahead and move to the second row. And in the second row, we're comparing G with this entire string that person B is sending. So in this case, if we do G versus G, there's a match. And so we take the diagonal plus one, which is going to be one. So in this cell, we're going to have a value of one. So there are no more matches in this row. What that means is that the rest of the row is going to keep carrying forward the previous value. And in this case, the previous value here is one. So we're going to just keep on adding one throughout this entire row up to the end. Again, because there's no other match to the value of G that we have found. Now from here, let's move to the next one. So when you go to the next, which is T, again here when you talk of G, the same case is going to apply on this side. On this other G, we're still going to have one up to the end because again there's no other match from what we have. So we just add one up to the end. All these numbers are not aligned, but at least everything is in its own cell. So now we move to T. Now, for T, again, we're still comparing with the string that person B is sending. And in this case, we're going to find a match for T, which is here. But for the previous values that don't match, we're going to maintain one, which is the longest sequence that we have so far. But when we reach here, now we have the diagonal plus one, and now this is going to be two. So the match on this is going to be two. So far, the longest sequence that we have found is G and T. That is why we have this two here. But if you check throughout the rest of the rest of the other cells here, we're going to still maintain the two because there's no other match across all of them. So we have also two here at the end. Then we're going to go ahead and after finishing with T, you can go ahead and start with the other one. So let's try and maybe look at A. Yeah, let's look at A. So if you look at A and G, we already had everything for A and G earlier on. So we're going to just maintain but now the longest sequence for A and G up to this point was already one. So we just maintain one here, one here. But when you got to T, that is when we had the sequence GT. So in that case, we're going to maintain, so from here, we're going to maintain two, and we're going to maintain 2 here, but now there's another match for A. So A has another match here. And then when you add 1 with the diagonal, this becomes 3. And now we maintain 3 throughout this. 3 now is the common sequence that we have. Now we have GTA as the longest sequence thus far. So what you're remaining with is B. So comparing B with with this string that we have up here as well, what we're going to do with B now is we're going to the match here. The match is found here at the end, right? The match is found at the end where we have B. So for the previous values, where we're comparing G and X, so these are going to maintain the previous sequence that we had. So this is going to be 1, then this is going to be 2, this is going to be this should be 2, this is also going to be 2, and we maintain still 3 here, which is the longest subsequence so far, and we're going to maintain 3 as well. Again, we still have GTA up to this point. Again, do note that we started having 3 that meant we got a match with A here. And finally, now we have GT and B. B is a match. So here, adding the diagonal plus 1, then the final cell is going to have 4. So what this means is that this ideally means that now the final LCS. So here the final LCS, or the longest the longest common sequence finally here is going to be GTAB. Should be in uppercase. GTAB, and it has a length of 4. So it has a length of 4. That is our longest common subsequence. So the number 4 tells us the final length that we're looking for. Yeah, and that is basically how you construct this table and fill it to the end. So now we're going to just go ahead and look at the code for representing this entire thing in the next video.